So to wrap it up, I think it's instructive to look at the different types of disinfectant actives that we've talked about in a form of a report card. So when you evaluate the different disinfectant actives across these 5 different dimensions, broad spectrum of activity, contact time, superior cleaning, safety, and environmental profile, you can see that there is no single active that has a high score across all of them, except perhaps accelerated hydrogen peroxide. And the reason was that the disinfectant was actually formulated with all those 5 dimensions in mind from the beginning. So one topic which is of high interest always is a topic of disinfectant rotation. Disinfectant rotation is necessary where certain conditions are met by the actual disinfectant product being used. For example, when one uses a disinfectant that has a gap in the spectrum of activity, disinfectant rotation becomes a prudent practice. Let's take quats as an example. Quats have a gap in activity against gram-negative bacteria and against non-enveloped viruses. Continual use of a quat disinfectant as part of the environmental disinfection program will result in the selection of gram-negative bacteria and non-enveloped viruses and build up their background numbers. At this point, it's necessary to switch disinfectants. Another reason to rotate disinfectants is when one is using a disinfectant that is prone to resistance development. Let's take the case of quats as an example. Quats are molecules that have a positively charged end. Environmental surfaces are typically negatively charged. When one applies a quat to an environment, there is a very strong adsorption phenomena of the quat molecules to the surface in the environment. This means that there is a monolayer providing a continual low-level exposure of quat chemistry to the existing microbial population. Eventually, these organisms learn to live in this low level of quat and develop resistance to it. When that happens, it's prudent to switch the disinfectant. Another reason to rotate the disinfectant is if one is using a disinfectant that doesn't have a continual relationship between concentration and contact time, meaning that no matter how high concentration of disinfectant we're using, we're not able to inactivate certain types of microorganisms. A good case in point is bacterial endospores. If one uses a disinfectant that is not effective against bacterial endospores, by the selective process that we talked about before, you are going to have an increase in the background number of these spores. At that point, it's necessary to bring a disinfectant that has some activity against these organisms to bring the background levels down again. This is why using a disinfectant that has a continuum between concentration and time is important. Oxidizers meet this profile. As an example, the concentration of bleach can be dialed up or down depending on what type of organisms you'd want to destroy. In theory, if one uses bleach as a disinfection program, it would not be necessary to rotate, simply to dial up the concentration of bleach whenever one wants to get rid of persistent species in the environment. However, the drawbacks of bleach are well known: corrosivity to skin, corrosivity to eye, and corrosivity to materials. One alternative is the use of accelerated hydrogen peroxide in lieu of rotation program. The idea would be to use accelerated hydrogen peroxide as your daily disinfection program, but every once in a while, instead of switching to a different disinfectant, you switch to a stronger concentration of AHP. This ensures that selective accumulation of background organisms does not occur without the need to switch disinfection products.